Acme is widely recognized for manufacturing agitators and for its expertise in selecting the most suitable impeller for reducing batch time, increasing yield, and decreasing power consumption based on specific process requirements. We offer top entry, side entry, and bottom entry agitator systems designed to meet a wide range of industrial applications. At Acme, our agitator design philosophy is based on flow, shear, or a combination of both. The selection of an impeller depends on the application, such as heat transfer, blending, solid suspension, reaction, or gas-liquid dispersion, as per the process requirements may range from high flow, low shear to low flow, high shear mixing conditions. The power requirement of an impeller depends on the types of application, impeller type, the desired mixing intensity and fluid properties such as density, viscosity, particle size, and solid concentration. Acme uses internally developed design software to determine the optimal agitator speed and configuration to achieve the required process performance efficiently. In this study, we compare a pitched blade turbine, Pvt, with a narrow blade hydrofoil impeller. Impeller efficiency is evaluated using the flow-to-power ratio. Hydrofoil impellers primarily generate axial flow with downward pumping, whereas Pvt impellers produce a combination of axial and radial flow. CFD-validated flow patterns clearly demonstrate these differences. The Pvt features 4 blades pitched at 45 degrees, while the hydrofoil impeller uses 3 blades with a tip chord angle ranging from 12 to 35 degrees. The hydrofoil design incorporates blade twist, optimized attack angle, and refined leading edges to maximize flow, minimize torque, and prevent flow stalling. In gas-liquid dispersion applications, the Acme Pvt impeller effectively reintroduces gas present in the vapor space back into the liquid phase. In addition, the wide blade hydrofoil geometry promotes uniform catalyst suspension and strong axial circulation throughout the vessel. The hydrofoil impeller blade experiences approximately half the relative fluid force, contributing to improved hydraulic efficiency and lower power consumption. For low to medium viscosity industrial applications, a narrow blade hydrofoil impeller provides superior overall heat transfer performance compared to a pitched blade turbine due to higher axial flow, enhanced circulation, and more uniform mixing across the vessel.